Okay, let's unpack a technical shift that is really fundamentally reshaping how we view electric vehicles.
It really is.
For years, the conversation around EVs has been dominated by, two main things: range anxiety and charging speed.
Right. Always.
But the solution to both of those problems? Well, it's here. And it lives entirely within the vehicle's core electrical system.
The architecture itself. That's right. For our deep dive today, we are talking about voltage.
Voltage.
Specifically, the industry-wide move from the long-standing 400-volt system to the vastly more efficient 800-volt architecture. This is a genuine game changer, not just a small step up.
So our mission today is to take these pretty dense physics concepts and just explain them clearly. We want to show you the technical mechanics of the change, what it means for performance and vehicle weight, and how this new tech is already delivering these, well, revolutionary real-world range breakthroughs.
Yeah, like in the new Mercedes-Benz CLA.
Exactly, the 2026 CLA.
And look, if you are evaluating a future EV purchase, understanding this voltage shift is, it's non-negotiable.
Why so critical?
It helps you distinguish between an older, maybe more cost-optimized EV design and a truly future-proofed vehicle. Because this one decision, this one piece of architecture, it impacts everything.
Everything like.
Weight, maximum charging capability, thermal management, and, the overall driving efficiency. It's all connected.
Well, let's start with the basics then, the definitions. Because 400V and 800V, they're actually just nominal labels, right?
They are. The standard 400V architecture, it typically sees voltages between 300 and 500 volts. It depends on the battery state of charge.
And that's the current workhorse.
It's the workhorse, exactly. Powering the majority of non-premium EVs out there. Its major benefit is maturity. The components are high volume. The manufacturing is totally established.
And that lower cost gets passed on to the consumer.
Directly. It's helped to make EVs more affordable, which is a huge deal.
Okay, so conversely, 800V is the emerging technology. Its range is what, between 600 and 900 volts?
Typically, yes. And it carries a higher initial cost right now because, well, the supply chains are still maturing and the components are more specialized.
But the key thing we need to explain is why those performance benefits justify that higher sticker price.
And it all comes down to the relationship between voltage, which is V current, which is A, and power, W.
The power equation.
It's a simple one. Power equals voltage multiplied by current. That's it. That's what drives your motor and charges your battery.
So if I want more power, say to charge the battery faster, I have two choices. I can dramatically increase the current, or I can increase the voltage.
You've hit the nail on the head. And increasing the current is, it's the less efficient path. And here's why, and this is really the core nugget of this deep dive: heat.
Heat.
Heat. Heat loss is proportional to the square of the current. It's a fundamental concept of heating. P equals I squared R.
PIAR. So if you double the current,
you quadruple the heat loss.
Wow, that sounds like an electrical engineer's nightmare.
It is. Excessive heat means wasted energy, which reduces your range. And it requires large, heavy, complex cooling systems.
Which adds more weight and complexity to the car.
Exactly. But if we adopt 800V architecture, we can keep the current lower while delivering the same power. If we double the voltage from 400V to 800V...
we only need half the current.
Precisely.
Yeah.
And less current means exponentially less energy lost as heat. That directly translates into a more efficient car, so better miles per kilowatt hour, and therefore better range.
And there's a secondary benefit.
A fascinating one. Because the current is lower, engineers can use much thinner, lighter cables, smaller components.
So less copper, and copper is really heavy.
It is, and the savings are significant. This reduced need for thick cabling and big heat management systems, it cuts the vehicle's overall weight. It's another massive win for efficiency. It's this cascading set of benefits that all comes from just moving up the voltage ladder.
And does this affect the actual driving performance? Not just charging?
Oh, absolutely. 800V systems can deliver higher power to the electric motors more efficiently. This means faster acceleration, greater responsiveness.
And better regenerative braking.
Much better. The car can recover power more effectively without overheating components. It's a total performance package upgrade.
Okay, let's make this tangible. Let's use the charging scenario from the source material, because we need to see the real-world limitation of a 400V system.
Okay, so imagine you pull up to a modern, say, 180 kilowatt DC fast charger. The critical detail here is that this charging station has a maximum current output of 300 amps.
A 300 amp limit. Got it. So first we plug in a standard 400V EV. Remember, power equals voltage times current. So 400 volts, multiplied by that 300 amp limit,
Gives you 120,000 watts.
or 120 kilowatts.
Right. So even though the charger is rated for 180 kilowatts, the car, because it's limited by its 400V system, it can only pull 120 kilowatts from that station. It hits the current ceiling and would start to generate unsafe levels of heat if it tried for more.
The current is the bottleneck.
It is. Now let's plug in an 800V EV to that exact same charger. Same 180 kilowatts, same 300 amp limit.
Okay.
The math changes completely. 800 volts multiplied by 300 amps gives us a theoretical maximum of 240,000 watts.
240 kilowatts.
Which is way above the charger's max rating of 180 kilowatts. So the car simply takes the full 180 kilowatt the station can deliver.
So, same station. The 800V car gets the full power, but the 400V car is stuck at 120 kilowatts. It's a 50% charging speed difference.
In that specific scenario, yes. And that is the defining insight. Higher voltage means higher power potential and faster charging, as long as the station can match it.
The math works on paper, for sure, but does that theoretical boost actually translate into real-world wins? Let's transition to our case study, because one car is making headlines right now by proving this principle in, well, spectacular fashion.
Yeah.
The 2026 Mercedes-Benz CLA.
Mercedes has gone all in on this, and the CLA is their first demonstration of 800V in a platform that was designed from the ground up to really maximize these benefits.
We're looking at the CLA 250 Plus EV specifically. It's the rear-wheel drive, long-range version with an 85 kilowatt usable battery. Now, the EPA estimated this range at 374 miles, which is already pretty strong.
Strong, yes, but its real-world performance was, it was shocking. In the independent Edmunds real-world EV range test, the CLA just crushed that estimate. It achieved an astonishing 434 miles of continuous driving.
434 miles.
Yeah.
That's a 16% improvement over the official estimate.
Yeah.
That rarely happens with this kind of margin, and the context here is what makes it so important for you as a buyer.
Absolutely. The CLA 250 Plus starts at around $48,500. This makes it the least expensive car Edmunds has ever tested to cross the 400-mile real-world threshold.
The least expensive.
By far. It was only beaten out by the much larger and far, far pricier Mercedes-Benz EQS 450 Plus ESE. This is basically the democratization of extreme range performance.
And the charging speed metrics are just as compelling. They prove the 800V system is working hard. The CLA 250 Plus achieved an average charge rate of 193 kilowatt when charging from 10 to 80%.
And to put that 193 kilowatt in perspective, the testing organization translates that into miles per hour. The CLA scored 833 miles per hour on the charging leaderboard.
Which puts it where, exactly?
Second place overall. It actually beat the recently updated Porsche Taycan.
The Taycan, wow.
Yeah, which was long considered the gold standard for charging speed. It was one of the first 800V pioneers.
So it's hard to argue with a car that's delivering efficiency 16.5% higher than its own manufacturer's estimate. And it's a sales success, too. It was named European Car of the Year 2026. It's already selling really well in Europe.
The data is just so clear that manufacturers are rapidly adopting this architecture. It's not just Mercedes and the pioneers like Porsche, Kia, and Hyundai.
Right, Kia with the EV6 and EV9, Hyundai with the Ion IQ 5 and 6.
And you've got Lucid Air pushing even further with its 924-volt system. The Tesla Cybertruck is also using high voltage.
So this isn't a niche party anymore.
Far from it. Key mainstream players like Ford, Polestar, Volvo, Lotus, they are all committed to adopting 800V systems in their future models. This is demonstrably the direction the entire industry is heading for performance.
Okay, we've established the physics is sound, the real-world results are spectacular, but here's the major challenge, the reality check we owe you. All these remarkable benefits, the 434-mile range, the super-fast charging, they're only realized if the charging station can actually deliver that matching high voltage.
And this is where the conversation turns a bit difficult. We have this cutting-edge vehicle tech, but the charging infrastructure is lagging significantly.
How bad is the lag? Give us the numbers.
In the U.S., it's a massive bottleneck. Currently, only about 1.5%.
1.5.
1.5% of the total DC fast chargers in the U.S. are capable of delivering 800V output. And the growth rate has been described as stagnant.
Stagnant.
And in Europe, it's slightly better in the EU at approximately 3%, but still, woefully insufficient to meet what the cars can already do.
1.5% in the U.S. So that means if you buy this incredible fast-charging CLA, 98.5% of the time, you cannot use its full speed capability. That's a huge problem.
It's a huge problem. And the reason the gap matters so much is hardware. An 800V car can charge on an existing 400V charger, but it needs extra hardware built in. A DC to DC converter to step down the voltage so the battery can handle it.
And that conversion process itself slows things down.
Exactly. It limits the maximum charging speed. So the owner of a premium 800V car is essentially relegated to 400V speeds unless they find that tiny, tiny sliver of 800V infrastructure.
You've paid for potential that you can rarely access.
You've paid for potential,
Precisely.
precisely. And this leads to the massive financial hurdle. The investment needed to upgrade the entire network. Upgrading stations is a huge capital investment. It needs new hardware and often significant utility work.
And it's not just the charger itself, is it? We're talking about the grid being able to handle that load.
Absolutely. The jump to 800V doesn't just mean a faster charge. It means a much higher demand on the distribution grid. If you have multiple 800V cars pulling max power at the same time, that could easily strain the existing electrical infrastructure.
Which means costly and time-consuming grid upgrades.
Right. So what the source material stresses is we need a multi-pronged approach.
Not just hoping private companies will fix it.
No. Governments, utilities, and private companies have to collaborate on strategic infrastructure planning. We have to prioritize high-demand areas for 800D upgrades. The build-out has to be predictive, not reactive.
What about innovation to manage that power demand without always having to, dig up streets?
Innovation is key. We need to integrate options like mobile chargers, more renewables, and specifically large-scale battery storage right at the charging sites.
Battery storage on site.
Yes, by integrating storage, a charging hub can meet those high immediate power demands from 800V vehicles without putting that sudden massive strain on the broader electrical grid.
This has been incredibly clarifying. Thank you for helping us break down a topic that could so easily be dense and explaining it with such clarity.
My pleasure.
The conclusion seems undeniable. The 800-volt revolution is driving superior efficiency, breakthrough range like we saw with the CLA's 434 miles, and dramatically faster charging speeds. It is unequivocally the future performance standard for EVs.
It is. And as you look toward the EV market, remember this final provocative thought. While the 800V technology is here, it's proven, and it's delivering immense worth, the biggest decision you face as a potential owner is whether you're willing to invest in an 800V vehicle today.
Knowing the infrastructure isn't there yet.
Knowing that the infrastructure needed to maximize its full potential is still largely a promise of tomorrow. It's a fundamental calculation of future potential versus current charging reality.
That is the ultimate question to leave with. Thank you for joining us for this deep dive.